Picture this: billions of miles away from the hustle and bustle of our Earth, beyond our vast cosmic neighborhood, there lies an enigmatic world called K2-18b. Amidst the inky black void of space, a monumental discovery gleams. For the first time, carbon-bearing molecules, specifically methane and carbon dioxide, have been detected on this distant exoplanet. This breathtaking revelation wasn't made by just any telescope, but by the unparalleled eye of the James Webb Space Telescope. Now, why does this matter, and why should you care? Dive deep with me for a moment. When we hear terms like methane or carbon dioxide, it's easy to immediately think of our own planet, the vast marshlands releasing bubbles of methane, or the CO2 we've become all too familiar with due to climate change discussions. But finding these same molecules on a far-off world, that's where the plot thickens. But first, let's frame our story. The stage is a galaxy teeming with stars, planets, and endless mysteries. Enter K2-18b, a colossal exoplanet 8.6 times the mass of Earth. For perspective, that's like taking Earth and stacking it atop itself almost 9 times over. This isn't just any other exoplanet. It might even be a Hycean planet. A Hycean planet is a world that has the potential for a hydrogen-rich atmosphere and possibly even a water-ocean surface. You heard it right. Oceans, just like our Earth, but with a touch of cosmic mystery. When astronomers gaze into the vastness of the universe, they're not just stargazing, they're hunting for clues that might answer some of our most challenging questions. Are we alone? Could there be other life-sustaining planets? How diverse can these habitable environments get? This new revelation is more than just a piece of trivia for space enthusiasts. K2-18b's atmosphere, brimming with these carbon-bearing molecules, hints at a world unlike any other. It whispers tales of foreign skies and maybe, just maybe, secrets of life beyond our earthly realm. The very fact that K2-18b exists in the habitable zone, a sweet spot around its star where conditions might be just right for life, makes the discovery all the more tantalizing. The sub-Neptune world of K2-18b, positioned tantalizingly in the sheer Leo constellation, is a conundrum. Its size, dwarfing our planet yet puny compared to Neptune, makes it an unusual player in the cosmic arena. No counterparts in our own solar system, these mysterious sub-Neptunes remain an active puzzle for astronomers. If you think this sounds like science fiction, think again. This is the universe challenging us, taunting us with puzzles and riddles. With every molecule detected here, every shade of light analyzed, we inch closer to perhaps the most profound revelation of our time, that we aren't alone. The universe never ceases to astonish, and as our story unfolds, the saga of K2-18b deepens. This world doesn't merely revolve in some far-off detached corner of the galaxy. Instead, it's meticulously choreographed in a celestial dance around its parent star, K2-18, a cool dwarf star that paints a luminescent backdrop for our enigmatic exoplanet. Imagine the grandeur of it all. 120 light-years from us, this spectacle takes place in the constellation Leo, the mighty lion of the zodiac. It's almost poetic, isn't it? Now, let's zoom in on the importance of the parent star and its interplay with the exoplanet. Such intricacies of space tell a story, one not just of distance and orbits, but of atmospheres, potential life, and endless possibilities. Worlds like K2-18b, oscillating between the sizes of our Earth and Neptune, are rare treasures in the vastness of space. Their very uniqueness makes them an astronomical enigma. We have nothing like them in our solar system. These are not just any planets. These are sub-Neptunes, a kind of middle child in the cosmic family. Do you ever find yourself pondering what's out there beyond our familiar skies? Think about it. Here's a world neither Earth nor Neptune, presenting us with questions we hadn't even considered. What secrets does its atmosphere hold? What mysteries lurk beneath its presumed watery surface? The debate rages on among astronomers, with each revelation more intriguing than the last. This tale takes a particularly exciting turn with the concept of the Hycean exoplanet. It's not just a fancy term, it's a gateway into the diverse and dynamic possibilities of habitable environments in the universe. While we've spent years looking at rocky planets somewhat like our home, the larger Hycean worlds open new doors. They beckon us, whispering of atmospheric wonders and potential habitats. Niku Madhusudan, an astronomer from the University of Cambridge, throws light on this, emphasizing that our search for extraterrestrial life has perhaps been a bit narrow. It's like having looked for keys under the same street lamp, because that's where the light is. But what if the keys are somewhere else in the darkness, waiting to be found? Madhusudan's insights prompt us to widen our lens, to explore the previously uncharted terrains, to quench our thirst for knowledge. Aren't you curious? Could the introduction of the Hycean worlds redefine our search for life? Could the vastness of space be teeming with life, hidden in places we've never thought to look? K218b leads us to a groundbreaking revelation: methane, carbon dioxide, and perhaps even traces of a molecule with profound implications, dimethyl sulfide, DMS. The presence of these molecules is more than just an atmospheric detail. It's a clue, a hint at something far grander. It's as if the universe has dropped breadcrumbs, leading us on a trail of discovery. Why, you might ask, is the mention of DMS causing such a stir? This molecule, seemingly innocuous, holds profound significance for us on Earth. It isn't just a random chemical. DMS is primarily a signature of life. Yes, life. On our home planet, the main source of this molecule is none other than phytoplankton, from marine environments. So every time you stand on a beach looking out into the vast ocean, those tiny organisms beneath the surface are producing a molecule that might be a beacon of life elsewhere in the universe. But let's not get ahead of ourselves. While the idea is tantalizing, the evidence isn't yet rock solid. As Madhusudan rightly points out, further studies are paramount. These early observations, while promising, require validation. Can you imagine the next steps, the anticipation as scientists peer deeper into the atmosphere of K218b, searching for definitive evidence of DMS? The potential implications are monumental. What if on this distant world there's life as we know it, or perhaps life as we don't know it? As we consider these revelations, it's essential to remember that the mere presence of carbon-bearing molecules or even DMS doesn't equate to life. K218b is an enigma wrapped in layers of high-pressure ice, cloaked in a hydrogen-rich atmosphere, and perhaps crowned with an ocean surface. These Hycean worlds could hold oceans of water, but there's a catch. The waters might be scorching, possibly too hot for any life to thrive or even remain liquid. It's these nuances that make the story of K218b so compelling. Every discovery is like peeling an onion, revealing layer upon layer of complexity. We're not merely discussing gases and chemicals, we're venturing into the very essence of what makes a planet habitable. While we've unveiled tantalizing clues about this exoplanet's potential, it's vital to approach such revelations with a balance of excitement and skepticism. Because while K218b sits comfortably within the Goldilocks zone, the region around a star where conditions might be just right for liquid water, it doesn't automatically confer the title of life-bearing onto this distant world. Picture this: a planet that sits in the most optimal region where warmth from its star could allow water oceans to glisten under alien suns. The very thought sends shivers down the spine, doesn't it? But now add a twist. What if those oceans were scalding? Hot, much like the cauldrons in mythical tales? What if, despite being in the so-called habitable zone, the conditions on K218b were far too harsh for life as we understand it? Let's dissect that for a moment. The term habitable has taken root in our lexicon, often evoking images of Earth-like paradises. But in the grand cosmic tapestry, habitable is a complex, multifaceted term. It doesn't necessarily mean Earth 2.0. It could indicate a world where liquid water exists, but is mixed with other compounds that make it undrinkable. It could mean an atmosphere with breathable elements, but under pressures that would crush us instantly. Or, as in the case of K218b, it could be a world with an ocean surface, but where the depths might be boiling hot. As you mull over these revelations, think about the broader implications. How many other planets out there are on the cusp of habitability, teetering between being life's cradle and a sterile rock? How does our definition of life, based primarily on our Earth-centric perspective, limit or expand our understanding of the cosmos? In the annals of cosmic exploration, the James Webb Space Telescope stands out as a beacon of human ingenuity and our audacious attempt to unravel the mysteries of the universe. After all, the revelations about K218b aren't just about the exoplanet itself, but also a testament to Webb's unparalleled capabilities. Imagine, if you will, a detective with a magnifying glass so powerful that it can discern the faintest of clues previously invisible to the naked eye. That's the James Webb Space Telescope for us, a cosmic detective peering into the abyss. While the Hubble telescope in its illustrious career has changed how we view the universe, Webb has arrived to push those boundaries even further. A crucial feature of Webb's prowess is its extended wavelength range. To grasp the significance of this, consider the universe as a grand orchestra. Different instruments, or in this case, celestial bodies, emit their unique notes, many of which are beyond the hearing range of a typical audience. The Webb, however, hears it all. From the shortest blips to the longest hums, nothing escapes its notice. And it's this capability that has enabled it to capture such detailed insights about K218b with just 2 observations, a feat that would have required the Hubble to invest much more time. Moreover, its heightened sensitivity is akin to a finely tuned ear, capable of picking up the softest whispers amidst the cacophony. These whispers are invaluable pieces of data that, when pieced together, form the larger narrative of celestial bodies like K218b. In essence, the Webb telescope doesn't just observe, it listens, it understands, and it tells tales of worlds far beyond our reach. For all those space enthusiasts, budding astronomers, or anyone enthralled by the grand tapestry of the universe, ponder over this. The Webb is still in the early stages of its cosmic voyage. If just 2 observations could redefine our understanding of a distant exoplanet, imagine what treasures lie ahead as Webb dives deeper into the cosmic seas. Isn't it breathtaking to realize that we're living in an era where we're not just spectators, but active participants in these cosmic discoveries? As Webb continues its journey, what new frontiers will we breach? How will these revelations reshape our understanding of existence, life, and our place in the universe? With bated breath, we watch, we learn, and we dream. Having shed light on some of K218b's mysteries, the tenacious team of astronomers is far from done. Their next companion in this cosmic journey, the MIRI spectrograph aboard the James Webb Space Telescope. To the uninitiated, the name might sound like a sophisticated piece of jargon, but let's unpack its significance together. Imagine the universe as a grand stage, with every celestial body putting on a performance. Spectrographs like the MIRI act as our personal critics, dissecting every nuance of this performance. They separate light into its individual colors or wavelengths, allowing scientists to detect specific molecules in the atmospheres of distant worlds. It's akin to discerning individual instruments in an orchestra, each playing its unique tune. The anticipation surrounding the use of MIRI is palpable. What secrets of K218b will it unveil? Could it further validate the presence of life-indicating molecules solidifying or refuting the claims about dimethyl sulfide, or might it present entirely new facets of the exoplanet that have remained hidden thus far? For those of you at home captivated by this celestial tale, imagine being a part of this grand detective story. Every observation with tools like MIRI is a page turned, a clue found, a piece of the puzzle clicking into place. As the team embarks on this next phase, the world watches with bated breath. The beauty of it all? You don't have to be an astronomer to participate in the wonder. Each of us, in our curiosity and eagerness to learn, is an intrinsic part of this cosmic narrative. Amidst the vastness of the universe, nestled between stars and the void of space, is our shared singular quest, the search for life beyond our earthly confines. While our journeys to the moon, rovers on Mars, and probes sent to the farthest reaches of the solar system have made monumental strides, it's the exoplanets, worlds orbiting distant stars, that offer some of the most tantalizing possibilities in this grand endeavor. K218b is but a chapter, a fascinating one that propels us toward our ultimate goal. You see, finding water or certain molecules in the atmosphere of an exoplanet is akin to finding a piece in a vast cosmic puzzle, but identifying life, that's like seeing the whole picture come to life, telling a story that has the power to redefine humanity's place in the grand tapestry of the cosmos. Imagine for a moment the profound implications of such a discovery. What would it mean for our perception of life, its fragility, its ubiquity? How would societies respond, religions adapt, and philosophies evolve, knowing that the spark of life isn't unique to our pale blue dot? It's a game changer, a paradigm shift, a new dawn in our cosmic understanding. Now, connect to that sense of wonder you feel looking up at a starry sky. Each pinprick of light might be hosting worlds of its own. The very thought that one or many of these distant worlds might be teeming with life, be it simple microbes or complex organisms, is both humbling and exhilarating. It binds us in a universal narrative of existence, a tale where Earth is just one of the countless worlds where life has managed to gain a foothold. But this journey is fraught with challenges. Space, as we know, is vast and mysterious. The distances are immense, the conditions extreme, and the variables countless. However, every step we take, every observation, every molecule detected, brings us closer to answering one of the oldest and most profound questions. Are we alone? So, as researchers continue to probe the depths of space, and as telescopes like Webb pierce the veils of distant worlds, remember that we are on the cusp of discovery that might just rewrite our cosmic story. A discovery that emphasizes the interconnectedness of all life and underscores the sheer wonder of existence, the vast diversity and uniqueness of the worlds scattered throughout our galaxy. You'd think that within the confines of our own solar system, we'd have examples of every possible kind of celestial body, right? But the universe, in its characteristic style, always finds ways to surprise us. Enter the enigma of subneptunes, like K218b. Within our own cosmic backyard, we find nothing like them, neither as rocky as our Earth nor as gaseous as our Neptune. These planets are, in essence, the middle children of the cosmic family, neither here nor there. But here's where it gets fascinating. While our solar system seems to have skipped over this category, the wider galaxy is teeming with them. So we find ourselves in a universe where the norm, in planetary terms, is what's absent in our immediate surroundings. Imagine walking through a vast forest where every tree, to your knowledge, is an oak or a pine. Then one day you stumble upon a grove where every tree is a species you've never seen before. That's the kind of revelation subneptunes bring to astrophysicists. And while we might have once believed our solar system's blueprint was a standard template,